We are on the section 6.3 and 6.4. The complement of a set, the union and intersection of two sets on your page 52. This would be last portion we are learning in this class. Okay, so we see. And for chapter 6, what we have been learning? Last time, we were talking about the vocabularies and the operations, right? The sets, Venn diagram, and the operations are what? The complement and union and intersection. So let's see how we are going to use those. You need those for your sets. Okay, so take a look. And on your page 52, the complement of sets. Okay, it says complements come up very often in statistics. Recall that the complement of set is it's everything that is not in that set, right? Sometimes it is much easier to find the probability of a complement than of the original set. And there is an easy relationship between the probability of an event happening and the probability of the complement of that event happening. Okay, so the formula is this way. The probability, we use P for the event A. That means the things will happen for the event A. Then for the things not event A, okay? So probability not event A. So things either happen or not happen. Total is what? 100%, right? 100% is 1. Either happen or not happen. If total is 1, they add up together is 1. If you use 1 minus not happen, things that would be your what? Probability of happening. Okay, so the formula is this way. We just introduce the symbols for you. Then you will actually calculate the probabilities in stats class. Now we just introduce the symbol, how to do the complement of a set first. How to do the complement before we do the probability. Okay, so look at the first one. Find the complement of the set, this one. If A is a set, right, which has X in there, then we describe X after the bar. So say X is less than 4. A is a set less than 4, can be what? 3.8, 3.5, 3, 2, 1, negative something, right? Then what is complement? Its complement will be what? Not this one. So X is what? Less than 4 here, right? Not including, so not include there. Then what do you think? The complement would be what? Not this part. That would be what? This part. Do I include this? Yes, from here on. So the complement would be what? The X would be what? Greater than or equal to 4. That will be your complement set. Okay, so we are learning how to find the complement of a set. Let's look at the next one. It says, when computing probabilities, the complement is sometimes much easier than original set. For example, suppose you roll a die, right, 6 times, and wanted to find the probability that the number 3 come up at least once. Find the complement of this event, right? So you have a set like this. Then probability we want to find is what? Find the you roll the 6 times, right? Then find out the probability that the 3 come up at least once, at least, that's the event, at least once, for what? Number 3. Okay, so you rolled the die, right, 6 times separately, right? So for the first time, can be 3, can be 9. So at least once, can be here, 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 right? Then it's really complicated. So it may happen what? At least once means what? Maybe once, okay, once, maybe twice, or 3 times, or 4 times, or 5 times, or 6 times, right? You might happen 3 here, may not, all right? So at least, maybe here, maybe all of them, right? Then you find the probability that it's very hard to count. What do you think? At least once, or not at all, right? So all you have to do, because it can be once so many times. So what do? You actually do is what? Find the probabilities, not 3 at all. Then if none of them is 3, the chance, then you do 1 minus 1, because not 3 at all is much easier than count the 1s, 3, 2, 3, 6 times. So not 3 at all, none of them is 3, then you use 1 minus that, then you can find your probability. Okay? You actually figure out what is not 3 at all in the stats class, but we just give you the concepts. You can use the complement of a set concept to actually do that. We're not going to test your probabilities, but we just give you a concept. Look at next one. Suppose that we want to find the probability that at least 20 people in the class have done their homework. Find the complement of this event. Okay, we want at least 20 people in the class have done their homework, right? So you might have 1 person did the homework, 2 person, or 3, all the way 17, 18, 19, then 20, 21. You might have so many people did homework, but at least 20 means what? At least 20 or 21. Say we have 50 people in a class. Maybe 20 of you did homework, or 21 or 22. But 1 to 19, or maybe 0 even, didn't do any homework. Okay? Then we want you to find the complement of this event. Okay? So we are going to use X to show. Here is the people who did the homework, right? X is what? Number of people in the class did homework. Okay, so if set A is what? Did homework. How do we show? That's X people, right? Maybe so many, depend on how many. So X is what? At least means what? Bigger than or equal to do that. Or you can say, oh, 20 people did, or 21 did, 22 did. So that represent the idea of A, right? What is complement? Complement AC, right? Then how do we show X? X is what? Not bigger than 20 or equal to, is what? Less than 20, right? x is a whole number. Or you can show it's what? 0, right? 0 all the way to 19. 0, 1, 2. Remember our da da da, right? All the way to 19. We can do that way, right? Or we can show x is what? X less than or equal to 19. X is a whole number. Maybe easier for you just to show 0 to 19, right? Or you use the x with set symbol to show the idea as well. You can do either way. All right, we just show you the idea of complement of set and how do we use it. Next one. Suppose a number is picked at random from the whole number from 1 to 10. We are going to pick the number 1 to 10, right? And let A be the event that number is both even and less than 8, right? So the event is what? The event is even number or less than 8, okay, and less than 8. From 1 to 10, you just pick a number. Can be even, can be odd, right? Then you want to be less than 8. So what kind of event? So the event is A. What kind of number can it be? Can it be 1? No, not even. So it will be 2, 4, 6 even, right? Can it be 8? No. Can it be 10? No, because it has to less than 8. So your event A, actually it's only 2, 4, and 6, right? You want to find you the complement of A. What's complement of A? Not those between 1 and 10, right? That will be 1, 3, 5, not a 6, 7, 8, 9, 10, all the way up to 10 because that's the number we use, right? That's how we find it for the event. You show that way, and the complement, we show it as such, right? Next one, that A be the graph of complement of the interval A 2 to 4. So this is a 2, this is a 4. That's our event, right? The interval. You want you to find the complement. Complement means what? The outside of it. So outside of it is what? This one actually is like this. Solid dot, this is like open dot. So the complement will be what? Outside of it. Outside of it, not including 2. So it will be here, then outside, all the way here, right? And after 4, including 4, right? That's 2, that's 4, including 4, all the way to there. That would be your A complement. Right? Let's look at number 6. Some calculators can only find the probabilities for values less than a certain number. If we want the probability of an interval greater than a number, we need to use the complement. Suppose that you want to find the probability that a person will have traveled to more than 2 foreign countries in the last 12 months. Find the complement of this and graph it on the number line. So we are going to do what? We want to find the complement of something, right? Complement of in the past 12 months, then who has traveled to more than 2 countries in the last 12 months. Okay, so for the last 12 months, we are talking about, so travel more than 2 countries. So it says the person will travel to more than 2 foreign countries. So in 12 months, okay, let's see, are they talking about months or travel more than 2 foreign countries? So let's read the question again, okay? So it says, suppose that you want to find the probability that the person who will have traveled to more than 2 countries in the last 12 months, okay? So for the last 12 months, find the complement of this. Oh, it's so confusing. Are we going to find the months or find the more than 2 countries? I think it's months because they say who will travel to more than 2 countries. So we are talking about the person who traveled more than 2 foreign countries within the 12 months. So let's see. Oh, it's confusing. Okay, let's read the question again. Suppose that you wanted to find the probability that the person who will travel to more than 2 countries, right, in the last 12 months. So we are talking about in 12 months of times, okay, find the complement. Oh, it's so confusing. Oh, let's skip this. Okay, I cannot even follow the question. I copied from book. So let's skip this. And when you do the homework and the test, it will be obvious. All right. Let's look next one. Okay, we are going to talk about, we talk about complement of set. Let's talk about union and intersection. Okay, the union and intersection of 2 sets. Read your paper on your page 53, okay? All statistics classes includes questions about probabilities involving the union and intersections of sets. In English, we use the words or and, okay, to describe these concepts. For example, find the probability that a student is taking a mathematics class or a science class that is expressing the union. When you say or, take either math class or science class, or either or, then you do union. Okay? What is probability that a nurse has a bachelor degree and more than 5 years of experience working in the hospital? That is expressing the intersection of 2 sets. Okay? Because when we say, okay, a bachelor degree and more than 5 years experience. If you want to hire somebody with bachelor degree and with more than 5 years experience, that means you have to have both. That's and, right? Then you have to do intersection. In this section, we will learn how to decipher these types of sentences, and we learn about the meaning of unions and intersections. So we are going to translate the English to math, to stats, with union and intersection, right? In algebra, we learn what basic operation is this. Then in probability and stats, okay, in stats, we do union in operations, union and intersection and complement. Okay, different operations. So on your paper 53 in the middle, it says an element is the union of two sets if it is in the first set, the second set, or both. Okay, union can be either or both. The symbol we use is intersection, either or both. Okay, that means or means either or both. Okay, the word you said often see indicate is by or. Okay, so let's see some examples. Example 1, consider the following sentence. Find the probability that a household has fewer than 6 windows or has a dozen windows. Write in set notation as a union of two sets and then write out its union. So we are talking about two sets, right? Find the probability. First probability for the event, for the who has fewer than 6 windows. So if your house has less than 6 windows, how many you can have? Up to 5, right? You may not have a window. You have 1, 2, 3, 4, 5 windows, less than 6, right? Or has a dozen windows, or, okay? Another set is what? A dozen windows means how many? 12. It says you either has less than 6 or 12. Can be either or both, not both, right? But you have to describe the situation is what? You have so many windows or you have a dozen windows. So you show it by union this way. Look at the next one. Consider the following sentence. Find the probability that the number of units that a student is taking is more than 12 units and less than 18 units, right? Assuming that student only take a whole number of units, you don't take half units. We are talking about just a whole number. Write this set notation as an intersection of two sets and write out this intersection. So first one is saying what? Student is taking more than 12 units and less than 18 units, right? So what do you think? If you say the person take more than 12 units, not 12, more than 12, right? So supposed to be 13, 14, 15, all the way to what? Less than 18, so 16, 17. So that's what we are talking about, right? The person either take 13 units, 14 or 15, 16, 17 units, because more than 12 and less than 18. That's what the statement is saying, right? But we want you to learn, find the two sets, okay? So one set is talking about what? More than 12 units. That would be 13, 14, 15, all the way on, right? More than, that means more than 12 units. Then, or it can be what? Less than 18 units. Less than 18 units would be 1, 2, 3, all the way to 18 units, right? Then we talk about less than 18 and more than 12. Two things, more than 12, less than 14. But when you say and, that means what? You do intersection. A intersect B. So you see, A intersect A, intersect B. So it will be 13, 14, 15, all the way to 18, 16, 17, and all the way to 17, right? All this. So this portion is what? Intersection. So that would be your intersect. Okay? Intersection. So what we are talking about is when we talk about in terms of English, the sentence, then how do we relate to the set symbol instead? And we are going to use this concept, translate English to the set symbols, and we are going to do the probabilities on it. Okay? Let's look at the next one on your page 54. Example 3. Consider the following sentence. If you roll a six-sided die, find the probability that is not even and it is not a 3. Okay, that is not even and it is not 3. Write this in set notation. Okay, so if we roll a die, right, then it can be what? Can be 1, 2, 3, 4, 5, 6, right? That's our event. Can be which number you roll, right? Then you want you to find what? The probability that is not even and it's not 3. So it's not even, it's not 3. So it should be what? 1 and 5, right? So the answer should be what? 1 and 5. Then we want to practice the set symbol. So it's talking about event, okay? Event, not even, and not 3. So let's see if it's even, right? If it's set for the A, it's even, that means what? 2, 4, 6, right? And not even, that will be what? A complement, that will be 1, 3, 5, right? And if it's a B is, say, 3, for 3, right? So B is 3. If it's not 3, that would be what? B complement. That would be 1, 2, 3, 4, 5, 6, right? Then we say not even, not 3. So we want these two conditions. That means A complement and B complement. So it's A complement is what? 1, 3, 5. Then B complement is what? 1, 2, 4, 5, and 6, right? We wanted to find a situation like this. So 1, 3, 5, 1, 2, 4, 5, 6. What's in common? 1, 5. So you end up what? 1, 5. That would be the answer. It's the same thing as we just do that. But sometimes it's not that simple. Then we need to use the complement concepts to do that. Right? Let's repeat because you definitely need this later on. So we say find the event, okay? If you roll a six-sided die, find the probability that is not even and it's not 3. So it's not 1 to 6, not even. So you get rid of this, not 3. You end up 1, 5. You can do it directly. But sometimes it gets complicated. We want to use complement to do it, okay? So first, we say not even, not 3, right? So you have to find the even first. Even would be 2, 4, 6. And 3 would be 3, right? Then not even, between 1 to 6, not even would be 1, 3, 5. And not 3 would be what? 1, 2, 4, 5, 6. Then you want to have what? Both, right? Not even, not 3. So it would be complement and complement. not even, not 3. So you do intersection of A complement and the B complement. So not even, not 3. So we have what in common? So for this, not even, not 3. That would be these 2. That's how you do it. Okay? Look next one, number 4. Consider the following sentence. So we are translating English sentences to the set operations. That's what we are doing. Okay? So, number 4, consider the following sentence. If you randomly select a person, find the probability that the person is older than 8. We want something older than 8. And or is both younger than 6, and is not younger than 3. Write this in set notation. My goodness. Okay. Older than 8. First we say older than 8. That would be a person older than 8. That would be what? Older than 8. That would be 9, 10, all that, right? Or is both younger than 6 and not younger than 3. So for this one, younger than 6, it will be 5, 4, but not younger than 3, can be 3, 4, 5. Right? So we want to write it in set notation. Let's do the picture so we kind of know. Okay? So you have 3, 2, 3, 4, 5, younger than 6. All right. Okay, 3, 4, 5, maybe 5.5 or something. Okay. And or older than 8. So that's 8. Okay, older than 8. So that's the age selection we are doing, right? So if we do it in the set notation, that would be what? Like this, right? X is what? 3 less than X less than 6, right? And or this part is what? X, okay, that's right here. Union X, X is bigger than 8. Okay. Or you can write what? Together, or write this way. Okay, X is what? X is bigger than 8. Also can be X less than 6. So we can write this way. Okay? Good? Confusing, isn't it? Okay, that's your English. Okay. So this will cover our section 6.3 and 6.4, the last concept you are learning in this class, right? Wonderful. So what we have left to do is just do the review for Unit 5 and Unit 6, Chapter 5, Chapter 6. So that will cover all our class. Are we good? You need to practice, for sure, especially like those. Okay?